I want to show you this one here, 124 DLL Hijacking, which is very nice. And we've already done Process Explorer, and this shows you the joy of Process Monitor, another fantastic tool. Now, on this machine, all these things are already done. You have Defender and Metasploit is already installed, which is fine. And so now we can create a malicious DLL with Metasploit. So let me bring up my Windows machine, which is here. All right. And so I'm done with Ollie. Close whatever I can. Okay. And I just want a command prompt, and I think maybe I need administrator command prompt. Okay. So command, administrator command prompt. Okay. And now I need the instructions, of course, which good. They should be here, 124, because I certainly don't intend to type out that command. I'm going to copy and paste it. This runs the Metasploit framework, and it runs this thing called MSF Venom, which is the part of the Metasploit framework that creates malware, which is what we want. We're going to make a malicious DLL, and there it is. Now, I'm not in the right folder, however, so I don't want to do this now. I want to do this in, I think, my downloads folder. Yeah, so let me go there. CD users, IE user, downloads. All right. Now I want to execute that command that in the clipboard. This is going to create a DLL called shellbind.dll. And what that is going to do is it's going to run this exploit, Windows x64 shellbind TCP, that will open a listening port on port 4444, and anybody that connects to it will be able to take over the machine. So this is a simple kind of backdoor. It's not, by the way, a very powerful attack. Anybody that uses a firewall properly will block this, but this is a demonstration of malicious activity. So it's created a DLL file, 8,704 bytes big, and DLLs are dynamic link libraries, and this is a system Microsoft uses to make programs smaller and make them load faster, but it is dangerous and unsanitary. And this is the main technique used to infect Windows machines, is injecting code into the libraries. So let me make sure the firewall is off. If you don't do this, it will crash later, I found out. So Windows Defender Firewall is in fact off. It's red. Okay, you want to make sure it's off. All right. And now we can mess with a service. This, it turns out, you saw before looking at Process Explorer that there are a lot of services, dozens of them, running in a Windows operating system. And a lot of them are old and a lot of them are unnecessary. So you can mess with them. And here's one of the many that we can mess with called MSDTC. MSDTC, all right? It is the Microsoft Distributed Transaction Coordinator or something. And I don't really know what it does. We'll see the Microsoft description of it here soon. Microsoft, just a moment. Why am I having trouble finding it? MSDTC service. Distributed. Oh, it's not Microsoft. Distributed Transaction Coordinator. Okay. There it is. Distributed Transaction Coordinator. Coordinates transactions that span multiple resource managers like databases. So I don't really understand what it does, but it's not important on a normal Windows 10 box. It would only be important if I was a database service. And in fact, it's not even running right now. It hasn't started. All right. We can see how this is going to run if I go to Properties. And you'll see if you go to Logon, it's right now running as Network Service, which is one of those accounts that are available before you log in. I'm going to change it to run as the local system account. Most services do run as the local system, and I'm just going to make sure this one does too. All right, just as a demonstration, we could do the project without that, but I just got used to doing it this way. Now we're going to watch what happens when it loads this program. So we're going to start Procmon and set up these two filters. Process Monitor is fantastic. There it is, Procmon 64. Now what this is a graphical view into the Microsoft event logs. And you can see them, 117,000 events, 144,000 events. The event viewer is measuring an incredible number of events. And as you can see, it's going by too fast to handle. So I'm going to turn off the capture so it'll stop clicking events and then hit the trash can to clear them. And now at least it's clean. Now, obviously, I don't want to see 124,000 events. I want to see a couple of clearly useful events. So I configure a filter, which is this thing, the filter. And now I can make it right. So I want process name contains MSDTC. So that is process name contains MSDTC. I only want to see what that thing is doing, the distributed transaction coordinator. I add that one. And then I only want to learn about the libraries it loads. So I take path ends with .dll. So out of those thousands of events, it will just show me those events. Now I can start sniffing, and 11,000, but the filter excludes them all. So the events are going by, but it's not showing them to me because I filtered them. And now I'm going to start the service, which I can do right here. Distributed Transaction Coordinator, and start. Okay, so it's starting this thing, and now it's started. So I can go back to here and stop collecting. And now I have a list of all the results. And I think I can make the font bigger. Just a moment. Is options font. There we are. So let's just try making it bigger, like 12. And no apparent effect. That's rude. Options font. All right, maybe you have to change the family. That's what I usually did. I thought I didn't have to. Lucida, bold. Huh, all right. Well, anyway, it changes the font of the pop-up, but not the font of that window. Anyway, the point here is, you see what happened. It loaded various libraries, like ntdill, kernel-based dill, and so on. Then this one had some file locked, but it loaded. So as you go down, you see it loading lots of dills. Oh, that's weird. Huh, I had to scroll for it to take effect. All right. So now I've got to make this wider. There we are. Good. All right, so there's the results of things loading. All right. And there we are. All right, so there's the various libraries loading. And my graphics are a little fouled up here. But anyway, what I wanted to see was the ones that did not load successfully. And I wonder if there's a way to refresh the view. Doesn't look like there is. Anyway, I should be able to find something called, okay. Oh, right, this thing is really lagging and dragging up and down when I'm not doing anything. All right. Let me just do the capture again. Maybe it will remember the font. I'm going to stop the service and do that capture again and see if it'll show up with the bigger font. So this is Process Explorer. That's one thing about these cloud machines, Process Monitor. I've got some extra graphics processing going on. All right, this is bigger, and those are right. Now I can start sniffing. Let's see, I can rearrange the columns now. Wait, there we are. Ah, good, okay. So I'll start sniffing. I think maybe it was already sniffing. Dump, start sniffing. Now it's sniffing. Okay, now I start the process. In services, I say. Here's services. It's just slow. Okay, start. Okay, it's starting the service, and it worked. So now I can stop this. All right, this is good. Now I can see what I'm doing. So all these libraries, it looked for them and it loaded them, which is fine. And someplace down here is a library it couldn't find, which is what I'm looking for. Name not found. That was one of them. And there's another one coming, which is the OCL entry. Let me see if I can move around with the keyboard. It might be a little more controllable. All right. File locked. See if page down works. Well, that's good. Page down works. All right. So I'm just looking for the OCI library. There we are. So notice here, it did not find that library in oci.dil. Now, what this means is it loaded the program. Now, when you write code, you tell it what libraries are needed. And normally, if it can't find the library, the program will crash. But that didn't happen. The thing started, it's running, it's working fine. So that means this library was requested in the header part of the file, and it was never actually used. This is a fairly common mistake to make as you maintain code and you go through versions and versions of Windows as you use a library, and later on you delete the code that used that library and you don't realize you quit loading the library. But this is a vulnerability. This is the problem with Microsoft's dynamic link libraries. The developer writes code, and then you include a whole bunch of other code written in libraries that are not under your control. So how do you know that the code in those libraries is genuine? You don't. And that's the point. We're going to put malware in here instead of oci.dil, and it will just load it and run it. So that's the game here. And so now, if you open the thing in Process Explorer and look, you'll see it's running, but it doesn't have that library, oci.dil. It can't have loaded that library because that library is not present in modern versions of Windows 10. So all we have to do is put our malware in that location. And so we can do that from this administrator command prompt with those commands. So let me go down to the right part of the instructions in my virtual machine here so I can copy and paste. There we are. We just have to stop the MSDCC process and then take our malicious DIL and put it in C Windows System 32, oci.dil. And again, it didn't pay attention to my copy and paste, but if I do it again, I think it works the second time. And it does. So it stops it. Okay. And now I'm ready to copy my shell bind into oci.dil. And that worked. And now I can start Process Monitor again and start it and use the shell. So let's, are there any controls to prevent a user from creating system DILs? Well, there certainly are. For example, right now, I had to put it in the System32 directory, so I had to have local administrator rights. So this exploit is not really accomplishing much of anything. It's the next one I'm going to show you that really accomplishes something. This one is kind of weak. I already need administrator rights to get there. But the next one is the one that addresses your question. So let me run Process Monitor again, or I think I won't bother. I think I'll just run the shell. So now if I restart that process, which I should be able to just do with net start. If I just go back here and run net start now, net start, ms dtc. Okay, it starts, and notice it doesn't succeed in starting. It sort of hangs here because it's loading the malware, and these malicious DILs that are produced by Metasploit are actually pretty messed up. But they do the job. If I now do a netstat -an pipe more, I will find a listening process on port 4444. Now anybody can take over this machine. And I can do it locally, but from any machine that can reach this machine, I could just connect with netcat or ncat, the Windows version of netcat. ncat on 127.0.0.1.44.44, and now I'm in control of the machine, and if I do who am I am now system. So I've elevated above the administrator. I'm now running with the privileges of that process. So I was able to inject a malicious library, and the Microsoft Windows process just accepted it. It didn't check for a signature or anything, which is pretty rude. Anyway, so that is the exploit here, and let me just show you the next one, which is the one that's actually more powerful, because as Sumit pointed out in the chat, and this is not really accomplishing anything because I had to have administrator rights to do this, so I didn't really get much done. And the problem is those Metasploit DILs do not have any actual functions. They don't export any actual functionality. All they do is when you load the DIL, it runs DIL main, and they put all the malware right there in DIL main. So they only work, in this case, when you're going to load a library and then not use it. But you can fix that with DLL proxying, and that is 126. It's a little bit more of a process, but it's much more powerful. So here, if you look and you attack a different program called BG Info, so then you can make a BG Info. You put it in this folder, like you might have downloaded it or something, and when you load it with the same process, looking for the DLLs it loads, BG Info does something else interesting. It looks for this thing called version.dll to find out what version of Windows you're running, and it first looks in the folder where the software is, which is on the desktop in this case. And then only when it doesn't find it there does it go look for the real one here. Now this is what the United States used in the attack on Stuxnet. They had a USB stick that had a DLL on the USB stick. And when you run it, it would load the DLL right from the USB stick instead of going for the real system DLL. This is called DLL hijacking. It's also called attacking the load order path. You can it looks in a place of low privileges first, and it doesn't go for the high privilege location until that fails. So all you have to do is put a version.dll here in this low privilege area, like the downloads folder of the desktop, and it will be fooled by it. But if you try to do it with a Metasploit DLL of the kind we made, it won't work because the program will notice that the library it's loaded doesn't have any of the functions that were supposed to be in there. So to get away with this, you have to perform DLL proxying, which is why you needed Visual Studio. You use this thing called DLL Export Viewer on the real version, and you get a list of all the functions it puts out. Get file version info by handle, and so on. These are the real version.dll exports, and you create a proxy, and here's the source code for it. You just make this thing in Visual Studio. You can make a DLL that is a proxy DLL that will export those functions and just pass all the requests onto the real version.dll with these proxy linkers, and then you can add malware to it. And this one here just runs a batch line. It will run this thing called payload.batch. So it will load and totally fool the program, provide all the functions it expects, and everything will be fine, and then it will have additional functionality of doing whatever's in this payload.bat file as well. So this is more clever malware, and you can make a payload.bat file that just puts a mark on the desktop, creates a file called pwn.txt just to prove it works. And you can build this thing in Visual Studio. It's a little bit annoying in Visual Studio. There's some settings, little buttons you have to set, so I specified exactly this version and highlighted all the little things you have to adjust. There's a few little settings you have to make it run right, like this multi-threaded, and a couple other goofy settings. Not using precompiled headers, whatever those are. You have to get just those things set right, but when you're done, it will actually create this pwned file on the desktop. So that's the one that will actually really elevate your privileges. You have to make a more careful DLL injection. So try that stuff. That's fun stuff.